let's find the derivatives of these basic composite functions with arcsin, which is also sometimes written as this, inverse sine. I'll leave a link in the description to the lesson where we figured out what the derivative of arcsin is. This is the formula in the context of the chain rule, which is how we'll need it here since these are composite functions. The derivative of arcsin of u with respect to x, where u is a function of x, is u prime divided by the square root of 1 minus u squared. So let's get into these problems. Beginning with the derivative of arcsin of x squared, applying this formula for the derivative of arcsin of a function, we know the numerator is just the derivative of the inside function. The inside function is x squared, and its derivative is 2x. The denominator has to be the square root of 1 minus the input squared. The input is the inside function, x squared, and x squared is x to the fourth. So we're just squaring the input there, and that is our derivative. Let's move on to the second problem. The derivative of arcsin of 2x by the previously discussed formula, well, we need the derivative of the inside function in the numerator. The inside function is 2x, and its derivative is 2. In the denominator, we need the square root of 1 minus the input squared. 1 minus the input is 2x, so we need 1 minus 2x squared. But of course, 2x squared is just 4x squared, so we'll write it like that, and there is our derivative. In this last example, this formula does not apply because we don't have arcsin of some function. The thing inside arcsin here is just x. In this case, it's not arcsin, which is the outside function, but it's a thing squared, which is the outside function. The derivative of a thing squared, like the derivative of x squared, is just 2 times that thing. So we need to have 2 multiplied by arcsin of x. In the context of the chain rule, this is f prime of g. G is arcsin. Now we need to multiply by g prime, the derivative of the inside function, which in this case is arcsin. The derivative of plain old arcsin of x is 1 divided by the square root of 1 minus x squared. And there we go. That's the derivative, which we could rewrite as 2 multiplied by arcsin of x in the numerator divided by the square root of 1 minus x squared in the denominator. So those are a few basic chain rule examples involving arcsin. Let's finish with a little bit of a more difficult problem. You can give this one a try. Arcsin of 2e to the power of cosine x. In this one, arcsin is again the outside function, and this guy inside is our u. Let's do it. We know that the numerator needs to be the derivative of the inside function. Now that inside function is composite, so let's be careful here. The derivative of 2e to the cosine x is 2e to the cosine x, because the derivative of e to a thing is just e to the thing, but that thing is a function, so by the chain rule we need to multiply by the derivative of that inside function. The derivative of cosine x, the function inside the exponential, is negative sine x. So that's our numerator, the derivative of the thing that's inside the arcsin. And the denominator, just like before, it's the square root of 1 minus the inside function squared. So 1 minus 2e to the cosine x squared. And here's our final answer after doing some basic rewriting. I hope that was helpful. Let me know in the comments if you have any questions, and check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. Persistence, couldn't even open myself up for an instant. Was the law, but it was regular. I regulate my integrity. I'm a secular anesthetic from my own effigy. I didn't try just to be regular.